We have already studied some properties in the context of this chapter. This video is dedicated to another property set which will be helping us to solve more numerical problems in an easy and simplified manner. You see, I have 6 trigonometric functions, the inverse trigonometric functions written in front of us, and it is sine inverse, sin x, cos inverse, cos x and so on. And the answer every time that I have written is what? It is x. Remember the principal value branch video? We understood that sine inverse sin x is equal to x when what happens? When I have the value as the principal branch value, that is minus pi by 2 to pi by 2 for sine. Similarly for cos we had 0 to pi. Similarly for tan we had some value. Now in this video I am going to tell you what will the value of x exactly be for the condition to get the answer as only x. So let's write and learn side by side. Sine inverse sin x is equal to x for what? For all x belongs to minus 1 to 1. So whenever I have x in the range of minus 1 to 1, I have to simply write sine inverse sin x as the answer is equal to x. Similarly, cos inverse cos is equal to x. For what? For again, for all x belongs to minus 1 to 1. That means whenever I have x in the range of minus 1 to 1 and a question is given to me as say cos inverse cos theta. So the answer is simply theta, right? What about tan inverse tan x? Tan inverse tan x is equal to x for all x belongs to real numbers. Whenever I have x in the real number category, my answer is simply tan inverse tan x is equal to x. What about cosecant inverse cosecant x? The value for all x belonging to minus infinity to minus 1, minus infinity to minus 1, union 1 to infinity. If this is the case, my answer to cosecant inverse cosecant theta is simply theta. What about cot inverse cot x? Cot follows the same principle as tan. So I have for all x belongs to real numbers again in the case of cot x. Last but not the least, secant inverse secant x. Secant and cosecant follow the same principle. So the answer is x for all x belongs to minus infinity to minus 1 union 1 to infinity. Keep it in mind that infinity is an unbounded quantity, so you cannot have square brackets in case of infinity and minus infinity. But yes, definitely in case of 1 for secant theta and cosecant theta, my brackets have to be square brackets. They have to be closed brackets. So in this video, what did we see? In this video, we saw that I have certain conditions, certain ranges for which my answer is pre-decided. If I know cosecant inverse cosecant x as x in case of minus infinity to minus 1, I would definitely not be having any confusion and simply writing x in my answer. In the next video, we'll see some problems based on this concept and the other concepts which we have already studied earlier. We were basically solving some questions, we understood some concepts, and in this series of the same, we have the new topic. Let's read what the topic says. The topic is inverse trigonometric functions properties. We have already studied about some properties in this chapter already and have solved some problems also on the same. Now this topic is about the new set of properties and how will these properties be beneficial in solving the problems we will be seeing in the subsequent videos. Let's see what the set of properties are and what they have to say. So we already know what is sine inverse of x. Sine inverse of x is equal to x when for all x belongs to the range minus 1 to 1. That means I know the principal branch value or the principal value branch, and accordingly I have already learned in the previous videos, if you remember, about the values. But what if I do not have sine inverse x but sine inverse of minus x? So sine inverse of minus x, cos inverse of minus x, secant inverse of minus x, all these have the values as follows in the right hand side, whatever I have written. But when the value is in the principal branch value or the principal value branch, that means sine of minus x is equal to minus sine inverse x when x belongs to minus 1 to 1. All of you people who have watched my previous videos will not face any difficulty in understanding this. Right. Cos of minus x, cos inverse of minus x is what? It is not equal to minus cos inverse x like your sine case. Rather, it is equal to pi minus cos inverse x when x belongs to minus 1 to 1. What is the next one? Next one is tan inverse of minus x. So, tan inverse of minus x is minus tan inverse of x. It is same as sine case. When x belongs to all real is the range. Next is secant inverse of minus x, cosecant inverse of minus x and cot inverse of minus x. These all have the restrictions on the principal branch value. You know, for tan and cot, as we have already studied, the x belongs to minus infinity to minus infinity, that is whole real. For secant and cosecant, we have x belonging to the interval minus infinity to minus 1 union 1 to infinity. And for sine and cos, the value of x lies from minus 1 to 1. But the technique is similar in three cases. In which three cases? In sine inverse case, because sine inverse of minus x is equal to minus sine inverse of x. In tan inverse case, because tan inverse of minus x is equal to minus tan inverse of x. And in cosecant inverse case. So 135, that is sine, cosecant, its reciprocal, and tan. These follow minus of sine inverse x, minus of cosecant inverse x, minus of tan inverse x. But what about the rest? What about secant? What about cos? What about cot? They have pi minus secant inverse x, cot inverse x, etc. Right? Now, let's understand the proof of any of the two, and others you can prove similarly. So, taking the first one, sine inverse of minus x is equal to sine inverse of what is there? Minus would come in the front, minus sine inverse of x. Let's solve the proof and we will understand how the right hand side has come. Suppose I want to take sine inverse of minus x. Let sine inverse of minus x is equal to theta. If sine inverse of minus x is equal to theta, what is my next case? Sine inverse will go towards theta. So, I have minus x is equal to sine theta. This is very much clear. Now, if minus x is equal to sine theta, can minus be transported to the right hand side? Yes, it can be. So, x becomes equal to minus sine theta. Now, sine of minus theta we already know is what? Minus sine theta. We remember it from whatever we have studied about trigonometry in class 11th. So, I can write x is equal to sine of minus theta. Now, if x is equal to sine of minus theta, this sign would go towards the left hand side. Sine inverse of x is what? So, sine inverse of x becomes minus theta. So, I will be writing it towards the other side so as not to bend much downwards. So, it becomes sine inverse of x is equal to minus theta, which in turn minus goes again towards the other side. It becomes theta is equal to minus sine inverse of x. Now, what is theta? Theta is sine inverse of minus x. So, sine inverse of minus x is equal to minus sine inverse x. The proof of the first has been already done. Similar to first, we have tan and cosecant case. We already know the similar method to prove. But first, let me repeat the proof we did. We actually proved how and why sine inverse of minus x is equal to minus sine inverse of x. So what did we do? We took the left hand side, sine inverse of minus x as theta. We transported x and negative signs to get minus sine inverse of x is equal to sine of inverse minus x. One important step here was when you basically interchange these steps. X is equal to minus sine theta is actually equivalent to x is equal to sine of minus theta. So the first has been proved. What about the second case? Pi minus. Three things are there in pi minus. Let's take one and let's get started with the proof. The second was cos of inverse minus x is equal to pi minus cos inverse x. Let's take the second one. Let cos inverse, the question is what? Minus x is equal to theta. When cos inverse minus x is equal to theta, what is cos theta? My cos theta is equal to minus x. Minus can be transported? Yes, it can be. So minus cos theta is equal to x. Now, what is minus cos theta equal to? Minus cos theta is equal to cos 180 minus theta. Yes, we know, because cos 180 minus theta means cos in the second quadrant. Cos in the second quadrant is what? It is always negative. So this can be written as cos of pi minus theta is equal to x. Now cos of pi minus theta means what? If you find out cos inverse x, what is it equal to? Cos inverse of x is equal to pi minus theta, right? What is theta? Theta was what? Theta was cos inverse minus x. So my next step changes to replacing or substituting the value of theta as cos inverse minus x. So I have cos inverse x is equal to pi minus cos inverse minus x. The final step is this. What you can do is you can just substitute and replace the values. I mean pi minus cos inverse x can be taken here, cos inverse minus x can be taken on the left hand side. So in this video, what did we do? We basically learned, understood the properties, 6 important properties based on what? Based on the inverse trigonometric functions, wherein the angle minus x is given, not plus x. Plus x we have already done in the case of principal value branch. This is minus x. We already understood and learned how to prove. We took 2 cases, rest are similar, one can easily do. The proofs are usually not asked in the examinations, but it is important that if we go through the analysis, we do the proofs at least once by our hand, understanding it properly. In the next videos, we will be taking the subsequent concepts and we will follow the same. Say an important formula or an important question which is usually asked in the exams and is used in solving the other questions. The question is sine inverse of 1 by x is equal to cosecant inverse of x. We already know from our junior classes knowledge that sine and cosecant are basically the reciprocals of each other. That means if sine 30 degrees is equal to 1 upon 2, cosecant 30 degrees will be what? Cosecant 30 degrees will be 2 upon 1, that is 2. We already know this. Now, if sine and cosecant are inverses of each other, what about sine inverse and cosecant inverse? So you have to learn this and we will be proving this so as to make you understand more clearly that yes, sine inverse 1 by x is equal to cosecant inverse x, wherein the condition for x is what? X is belonging to minus infinity to minus 1 union 1 to infinity, which we have already seen in cosecant case. Right. Now let, the proof is somewhat like this, let cosecant inverse x is equal to theta. If cosecant inverse x is equal to theta, what do you mean by that? It means x is equal to cosecant theta. And if x is equal to cosecant theta, what do I have? I have basically cosecant theta's reciprocal as sine theta, x reciprocal as 1 by x. So it becomes 1 by x is equal to sine theta. And if 1 by x is equal to sine theta, I have theta is equal to sine inverse 1 by x. That is what we wanted to prove. What was theta? Theta was taken as cosecant inverse x. So I replace the value again, cosecant inverse x. That means sine inverse 1 by x is equal to cosecant inverse x. First thing. The second thing, if cosecant inverse x is equal to theta, that means what? That means my angle should be such that I should not have 0 in the denominator. You know that if I have 0 in the denominator, that means sine 0 is 0, cosecant 0 is what? 1 upon sine 0, which is not defined. So I need to take care that my theta is such that 0 is not there. So in case of cosecant inverse x is equal to theta, my theta is what? My theta belongs to the interval minus pi by 2 to pi by 2, both included, but I cannot include 0. Why can I not include 0? Because if 0 is included, 1 upon sine 0 will be 1 upon 0, which is not defined. Also, I know that my x belongs to what? Minus infinity to minus 1, union 1 to infinity. So in case of x, the interval is given to me, but what about 1 by x? So my 1 by x would belong to minus 1 to 1, because it is the case of sine, but again 0 is not included because denominator becomes 0, the things are not defined. So my 0 won't be included. You can also place 0 not in this bracket but in a bracket called as curly bracket. Both are fine, both the things are correct. So the video had the motive to prove sine inverse 1 by x is equal to cosecant inverse x. This is an important property which you need to remember. As such, proof I have already done. In the next video, we will be seeing the next important property whose proof we are going to see, but it is actually very much important as a question itself. Of properties wherein I have some addition relation, and you have to learn these properties by heart but also understand the proof, because the proof can come in the form of a question in your question paper. The property says sine inverse x plus cos inverse x is equal to pi by 2 for all x belongs to minus 1 to 1. Now I know that sine and cos have a relation as sine square theta plus cos square theta is equal to 1, but the story was long back. This is a new property which you need to understand and know, and you need to understand the proof also by heart. Let's see how to prove this property. I write the heading as proof, and it is what I have let sine inverse x is equal to theta. That means x is equal to sine theta. Also, I know that my theta should lie between what range? My theta should be something from minus pi by 2 to pi by 2. How? Why? Because I know that for sine and cos, the domain is such that it is from minus pi by 2 to pi by 2 and the range is from minus 1 to 1. You can put anything in between minus pi by 2 to pi by 2 in the case of sine and cos, and you get the results in the interval minus 1 to 1. Now, if I write the minus pi by 2 to pi by 2 in such a manner, is it incorrect? Less than greater than form? No, it is not incorrect. Now, another thing what I can do is I can replace or substitute theta by minus theta. So, if I have theta as minus theta, what will happen? Pi by 2 will become minus pi by 2 and that will come to the other side. And this minus pi by 2 will become plus pi by 2 and will go to the other side. What is the next thing? I need to add pi by 2. Why am I doing everything will be clear after 1 or 2 steps. So, what is my next step? My next step is to add pi by 2. So, it becomes pi by 2 minus theta. Here pi by 2 minus pi by 2 will be 0. And here pi by 2 plus pi by 2 will be pi. Let's put it in a box. We will be needing it later. Pi by 2 minus theta range is well defined, written in front of me, 0 to pi. Now the next step is we need to prove the things that we were taking. So if x is equal to sine theta, what else is sine theta equal to in the form of cos? I know sine theta is positive and cos 90 minus theta is also sine theta, because cos 90 minus theta means sine theta and it is in the first quadrant, so it is always positive. So I can also write sine theta as cos of 90 degree minus theta. Now taking x and cos 90 minus theta, what do I have? I have cos inverse of x is equal to pi by 2 minus theta. Now cos inverse of x is equal to pi by 2 minus theta. What was theta equal to? Theta was sine inverse of x. You substitute the value from equation number 1. So from 1 I have cos inverse x is equal to pi by 2 minus sine inverse x. And minus sine inverse x is on the other side. You want to take it to the side of cos inverse x, it becomes plus. So sine inverse x plus cos inverse x is equal to pi by 2. That is the result, and that is very much important. Why I found out pi by 2 minus theta? Because I wanted to check the pi by 2 minus theta as cos pi by 2 minus theta. 0 to pi is, the domain of cos theta, we already know, and here also 0 to pi would be satisfied. So in this video we saw the set of properties wherein the addition is followed and some value is obtained. We did the first one, sine inverse x and cos inverse x. In the next video we will be seeing the next proof. The proof of the formula again of tan inverse x plus tan inverse y, wherein since the conditions are different, that means x less than 0 is given to me, y less than 0 is given to me, and xy greater than 1 is given to me. So the formula also changes. As we saw in the previous two videos, the formula was tan inverse x plus y upon 1 minus xy. But in the second video which we saw, there was something called as pi, and here also we have pi, but it is minus pi. So as the conditions change, the basic formula also has to change, and this is what we will be seeing in the proof, that how the things vary with the change in the conditions. Let's get started with the proof. Keep it in mind that the proof is not very important, but yes, the formula you need to remember along with the conditions. That in certain condition which formula to apply, in this condition which formula to apply, and so on. Let's see. Suppose I have, as in the previous videos, assumed, let tan inverse x is equal to A, tan inverse y is equal to B. If tan inverse x is equal to A, tan inverse y is equal to B, what do I have? I have x is equal to tan A, y is equal to tan B. And if x and y are already known to me, and I also know one formula which I studied in class 11th, that tan A plus B is equal to tan A plus tan B upon 1 minus tan A into tan B, and this is a formula, so I will be keeping it in a box. Now what is the value of tan A? What is the value of tan B? As from the above step, I can substitute x plus y upon 1 minus xy, and here it is tan A plus B. Now keep it in mind, what is the condition given for x and y? Where is x? X less than 0, y less than 0, that means both negative. Negative plus negative will give me negative only. Come downwards. What about 1 minus xy? Xy is positive. Positive say 2. So 1 minus 2 is minus 1. Again negative. What about negative upon negative? Minus minus, do they get cancelled? Yes, they get cancelled. That means these both things will give me something called as positive. And if this is positive, so I have greater than 0. So I have greater than 0. So that means tan A plus B is greater than 0. And if tan a plus b is greater than 0, that means in which quadrant do a plus b lie? A plus b basically lies in either first or third quadrant. So I have a plus b lying in first or third quadrant, and I will be choosing any one of these quadrants. Let me choose third quadrant for my convenience. If I choose third quadrant, I have something called as what angles? I have something called as minus pi to minus pi by 2. Let me write everything down to avoid the confusion. We are doing what? We are basically having tan a plus b as greater than 0. That means what? That means a plus b lies in which quadrant? Either in the first quadrant or in which quadrant? The third quadrant. So the first or the third quadrant. Choosing any one of these quadrants can be up to us. Let's say we choose the third quadrant. If we choose the third quadrant, I have the value of a plus b revolving and rotating about which axis or which angle? It would be minus pi by 2 to minus pi. So minus pi by 2 to minus pi will be the angle. And again, now what do I need to do? I need to change certain things. That means if a plus b is given to me and I need to obtain minus pi later, so let me introduce pi at this very step. So I will be adding pi. So let me add pi and solve the rest here. So minus pi by 2 plus pi is pi by 2. A plus b plus pi is a plus b plus pi only, so it becomes pi plus a plus b. What is minus pi plus pi? That is 0. So I have the final range as pi by 2 to 0. Let's check what we did again to understand it better. I have something called as tan inverse x equal to a and b tan inverse y that we assumed. We have now values of x and y. We know the formula. So we substituted the values in this formula. So finally, finding the range from these, I got one thing to my knowledge, that yes, my values for pi plus a plus b would lie in something called as what? They would lie in something called as minus pi by 2 to pi added with pi. So things change. Now you need to know one thing, that yes, speaking technically, you have additions of pi, but is 0 greater or pi by 2 greater? So we need to shift certain things. Hence we shifted this. So I have 0 here and I have pi by 2 here. Because when you added, the axis would change. Definitely some things which becomes greater will become smaller eventually. Now 0 to pi by 2 is given to me. And what about tan 180 plus theta? Since it is always in the third quadrant and it is positive, so tan a plus b is same as tan 180 plus theta. And if these are same, what were the values? Basically they were x plus y upon 1 minus xy. And if this happens, that means pi plus a plus b, if you want to know what is pi plus a plus b, what changes will you expect? Only one thing, that the tan becomes tan inverse. So it becomes tan inverse x plus y upon 1 minus xy. And what is x? X, as we already know, was used here in the form of x plus y upon 1 minus xy obtained. This pi in positive goes to the other side, becomes negative. So I have the right hand side already with me. So a plus b is equal to tan inverse x plus y upon 1 minus xy minus pi. Now, what is a? A is assumed as tan inverse x. What is b? B here is assumed as tan inverse y. Just put the values. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy minus pi. Put the things in brackets, put the things in the box wherever needed, whenever needed. So in this video we saw the proof wherein the conditions of x less than 0, y less than 0, xy greater than 1 for tan inverse x plus tan inverse y.